to Victoria Game Engine series. This is episode 15.1, and today we're going to be focusing on bringing our variant class up to date with the rest of the engine. Now you may be wondering, okay, what's wrong with our variant type? And to be honest, it's not a great type, and there's a bunch of things that we need to fix anyway. But to give a brief example, so currently our arrays don't really work because our ref counts still cause like invalid freeze. That kind of stuff really shouldn't fly here. So what we're going to be doing today is we're going to be going through and making sure that our variant is one, more up to date, and two, has all of these failures out of the way. But mainly, we're going to be focusing on adding new features. There's a couple of things that I have developed that I usually would add in a lot later, but since we want to kind of keep the variant type fairly modern, we're going to be adding these now. To start this off, we're going to first go into typedef.h, and we're going to change some things. While these are great, these type names are a bit long, and honestly, if we're using them this way, I would rather just use something like stdint, but we're not using that. Instead, what we're going to do is we're just going to shorten the names. And the way we're going to do that is we're just going to get rid of the int bit and just say i8, i16, i32, and i64. And we're going to do this for pretty much every single one of these. And then we'll have to go through and update all of the code to make sure that those changes have been seen. So same kind of deal here, U8, U16, U32, U64. And here I am actually going to add type def float f32 and type def double f64. If we actually use these types, that depends. But now we're going to go into this option here in VS Code, and we're going to find every instance of i8, whole word and case, or int 8, sorry. And we're going to replace it with i8. We're going to hit Control or Enter. I'm going to do the same for every number ending. This will take a little while. And that's everything. That's all of that done. Now up here, what we're going to do is we're also going to make an include. And we're just going to include core error types.h. And main reason for this is that our error types should be available pretty much everywhere across the engine. Outside of that, there's a couple other things that we are going to add. Down here, we have, actually up here, sorry, we have a check full size T. So if you're on platform Linux, which we are, you want to define, or sorry, type def size type as size T. This is purely just because in some places we want to use size T instead of including it from stdint. It's by default defined on MSVC, but not defined on Linux. So we're going to leave it here. We're also going to go and add another preprocessor define, and that is for ifdest tests. We're going to define tests enabled, endif. And again, this is just to make sure that we do actually have our test suite. When we get to that, that's a long way off. When that's created, this will make sure that all of it's compiled, and otherwise it will not be compiled. Outside of that, there's a couple other things that we want to do. I'm going to paste these in. So effectively what we're looking at here is a kind of structure that we end up using where if we need a variadic macro, say n number of items, we need to expand that into every single version of that at compile time. And that's what these build indices are for. They don't actually contain any data. They are just to expand out that list. They're not going to be used in this video, but they will be used later. And to save us time there, we're going to just define them now. All right, so that is pretty much everything in this file for the moment. Of course, we'll probably end up coming back here at a later date, but for now, we're keeping this as is. And now time to actually move on to variant. Okay, so I kind of lied. There is one more thing that we need to do before we can actually start editing our variant, but that is that we're going to be adding a new type of macro and a new structure to our engine. So under variant, we're going to create a file called variant_caster.h. This is going to be a header on a file. And effectively what we're going to do is we're going to define a macro that we're going to be using in our engine. So again, pragma once. We're going to include our type defs as is customary. And we're also going to include variant.h. Because we're going to need a couple of things. Well, mainly we're going to need the variant. So the class we're going to be creating is called variant caster. So a variant caster, what it does is it takes any value and takes any variant value and turns the variant into that type. So the reason we're going to be using this is because we're going to need to create casting for certain types. We're also going to need this so that we can start using enums with variants, because by default, variants can't cast to enums because enums in C++ are treated as separate types to ints, so you can't do the implicit casting. You have to create this to do the explicit casting, if that makes any sense to anyone. With all that said, it's a dead easy class. I mean, it's no big deal. I'll just show you here. So it's a template. We're going to take type name T. Again, T can pretty much be any like fundamental or engine type as is needed. And it's called struct variant caster. Now, if you're wondering how this is called, it's actually called by the compiler. So we set up variant cast enum for each enum that we have. Then whenever we're changing a variant or assigning a variant to an enum, or we need to compare if a variant value is equal to that of an enum, it will look for a variant caster for that enumeration and then do the referencing, the type casting there. So what it takes is a static force inline t cast. Doesn't take a t by a reference, it just returns the value. And we take a const variant and p variant, and we just return p variant by default. Now this is for any type. However, we do need to define this manually in a certain way for each enum, and that is where the macro we are going to write comes in. So we're going to define variant cast enum enum. And what it's going to do is it's going to create a blank template class of struct variant caster enum. I'm going to take a static force inline enum cast of const variant p variants, and we're going to return enum p variant dot operator is 64, and just make sure that all of that is correct. Then from here, just make sure that we've got those backslashes so that the engine or C++ knows this is a macro type. So, and now we have this. And whenever we declare an enumeration that exists in core and we want our variant system to interact with it, we will declare variant cast enum. Just put the enum in and we'll get that all good. Okay, so this is also variant casted done. We're now going to move on to actually fixing our variant stuff and adding new stuff in there. So let's head on over there. If you remember from a million years ago when we first created this class, it didn't support many types. As you can see here, we still have some of those. We have nil, bool, int, float, array, and that's about it. But of course, now we have a lot more types. We in fact have a type that existed at first, but we didn't really implement it until now. We also have strings, so there's a whole lot more we can do with variants, and that is the point of this video. So up here, where we have our includes, we are going to want to include a couple more things. We're also going to want to first include call string vstring.h, and then we're going to do some type defs in order to make referencing engine stuff and any custom code we make easier. What we're going to do is we're going to use some specific types for certain vectors so that we can do some conversion between two. And what I mean by that is we're going to do some type defs. So for instance, vector u8 is a class that we might use a lot, and we're going to need a common way to refer to it that we can use in higher level code. So what we're going to do is we're going to call this byte array. From here, there's a couple more we're going to add. Rather than typing them out, I'll just add them for you as follows. Again, these are just types that we might want to refer to several times. So we just have common names for them so that they're a little bit more easy to understand. Then from there, we're going to add a few more types. So we're going to first make sure that we know that these are the atomic types when you can spell atomic. We're going to add string here. We're then going to have non-typed arrays. And then we're going to have typed arrays. And this is where our various arrays we declared up there will go in. And then we end on our types. But that's a few more that we now have to support. So let's go through and make sure we can do that. First thing that we really should do is we should go through and make sure that this list of needs freeing is updated, because when we do clear, it might cause some problems. So let's make sure we know what each type is. We know this is nil, and this is gonna be very repetitive. So I'm gonna speed this footage up and mute myself for a bit. And that's all of those updated. So now if we call to clear internals, it will actually clear the internals. Now there's a couple other things we're going to change here as well. For instance, get value as string doesn't really make sense anymore. So we need to update that. We also need to add operators for the new types and string. Same thing for constructors. Aside from that, we're more or less good. So let's just change get value as string to stringify. I'm going to declare an int recursion count 0 and make this const because we don't want to actually modify our data. The reason for recursion count I'll get to in a moment, but I'll try to explain when we get there. We also need to redefine that function, so we might be tearing a bunch of code out today. Also, these are the wrong way round. I don't know why. Just fix that. Right, now we need to declare some more operators. So I'm going to mute again, and I'm going to go through those. And that's all of those done. Of course, we'll need to go back and add all of the definitions for those, but for now, leaving as is. Now, there's one thing I forgot to do, so we're going to go and do this now. And in order to do this, we're going to save ourselves an include by going here and including core. No, it's core data atomic counter. We're going to need this for this class. We'll do that in a moment, but let's focus on variant for now. What we need to do is we need to define a structure that we're going to be using to reference our arrays. And it's going to look like the following. I'm just going to paste because it's not particularly interesting, but we do just want to get it done. So a class of ArrayRefBase, what it does is it contains a ref count. It can create copies of itself or return itself. It, again, has a ref count. It's a ref counted object. It's about as simple as it gets. And mostly this has like referencing from, so on and so forth. Most of the methods here are like static because they're just going to be called and destroyed and so on and so forth. And this is our way of fixing our problem with arrays. If the array is in a variant, it's now ref counted. We need to increment that somehow, and actually doing it is a bit of a pain. So this is the way to do it for us. Now there's an extended class. That's just one of ArrayRef. And this is the one that actually contains the array. It creates a new version of itself. The array itself isn't really accessed, but because it's a struct, all of these are accessed anyway. And the only reason we really need to do any of this is because in here, we need to create an array ref base pointer to array. And this is part of our union to make sure that, they're only so big. Another thing that I have here is this is now a size of double. And that's because by default in the engine, we are supporting double types flat out. And that's also a good thing to do because some of the other types that we're going to add, this 32-bit bytes may not be enough in some cases. Now this is all the stuff on the surface, so let's go below and edit the source file. Let's look at clear internals. What we're going to do here is first we need to actually have the case of a string. This one's basically the same. It's a reinterpret cast into string, the string pointer to data.memory, and then we just destroy the string. Nothing really interesting there, just do that by default. However, for our byte cases, we're going to be calling one of those custom methods, and that's ArrayRefBase destroy. If you remember from what you briefly saw, I know I really didn't go over it, sorry. All it does is decrements the ref count, and if that becomes 0, deletes the array, which is the one it's referencing, not itself, because of the way this works. And from there, if it's 0, the data will be freed. All good. Because again, this allocated memory is null at the moment. So From there, nothing happens by default. However, we do have some other things here. First things first, stringify clean. This just takes the variant and the recursion count and returns the string stringified, because for some reason when you call the variant stringify, it gets weird, so we call stringifying clean instead. So we take const variance p bar and the recursion count, and we just get a copy of the stringify from the recursion count, and then we just return whatever that is from there, like so. We also have another method here we call stringify vector, because all of these are vector types. So we take the vector itself and the recursion count, and from here we'll create a string just with an open bracket, and then for I0, I is less than the size of the vector. Oh yeah, this needs to be a template, by the way. I forgot to do that. If I is greater than 0, then we want to add a comma. Because again, stringify the internals, then add a comma, then continue stringifying internals. And otherwise, we just want to increment it by whatever stringify clean is. Taking pvec I and the recursion count. And once that's done, we want to add an end bracket and return the string. This is the main reason for stringify clean, is that sometimes if you would call to pvar.stringify, it would get messed up, and that really sucked. Just because of the nature of C++ being stupid. But this fixes it, and again, these are internal methods, so you don't actually expose these. They're not part of variants in any way. Now we get to edit this function. So we take string variance and change this to this. And now we are going to look at what we have. So int and float, if I remember. Yeah, I don't actually have these. So this kind of needs to stay this way. But everything else does have some operator. So we have a case for string, for instance, and this is literally just returning itself from the string pointer from memory. And then for an array, so in the case of an array, it kind of has some logic here. And what we're going to do is this. So this error message really isn't helpful, but I'll explain what's going on here. So with an array, you can add an array to itself. So you can say, okay, I want to append the contents, and I want this array inside of this array. Now that causes an infinite loop, because of course you're adding its own contents, and then whenever you try to print that, it will say, okay, you have this array inside which contains itself. So then we're going to have to get itself, and it keeps going on this loop. And so we increment the recursion count, and once that passes like 1024, too many and you'll run out of stack memory and you'll get a stack overflow. So from here, we just say, okay, don't do that. we're going to return an empty string. And then otherwise, you can just stringify it like any other vector. So stringify vector. And you just want to change it to an array, passing the recursion command in as well. And you'll probably imagine, because they're all very much the same, byte array, int array, and float array all look the same. And again, we do need to go back and add these. I didn't actually realize that we didn't have these, but they will be needed to be added at some point when we go and upgrade our string class. So then heading down the file, we're probably going to want to look at... Right, we're going to add another function that I apparently missed. Yeah, okay. So new function time. This is one called ref. So the definition for this function will be as follows. I'll just do my best to explain. So all it does is it first clears to make sure that, you know, the data is gone. Then it assigns the type to whatever we're trying to make it. And then we do some form of assignment. Usually, if it's cleared, it means that all the memory from the array that we created or whatever's held in that memory is elsewhere in code, so it won't get garbaged. And that means that we can do this allocation. So the means is here, if it's nil, we don't do anything. Bools, simple assignment. And otherwise here it's a placement new. So we place it in the memory from a string. We typecast that memory into a string pointer like so. Do the same kind of thing here. Apparently my array constructor isn't const. Hold on. That's just so ridiculous to me. I'm gonna fix that now. That's stupid. Why wasn't it const? Like, ridiculous. Anyway, for the case of byte array, we just do a typecast. So we get the other one's data, cast that to array ref of u8, then call to reference so that pointers is set up appropriately. And if it is null pointer, that means that the other class wasn't actually an array, so we just create one anyway. And it's the same here, so that's that explained. Now we need to update our operator equals. So sometimes if two of the variants are of the same type, say you have two arrays or two integers, they'll be able to interop fairly equally. But if they're not equal, you need to reset this variant to be the same type. And that's the reason we have ref, is because we need to reference it based on that data, change our type totally. And otherwise we do this. So first things first, we need to make sure that in our assignment operator, we actually do this check. So if our type is not equal to the other variant's type, like so, then we're gonna have to reference it, like so. And then we can just return, because we don't want to actually do any of this. That'll just be redoing what we've already done. Otherwise, we don't set it to null pointer because that use case has been changed. And we also don't need to do this type assignment because they should be the same type. So I can get rid of that as well. Aside from that, it's just things like adding case for string, adding case for array, which has already been done. That's sorted. So what they do is they get the left and the right. If they're not equal, then they're false, otherwise true. I do realize now that instead of inverting that, I could just do not equals. Reason being that it generally doing, if they're not equal, they'll find that pretty quickly. But if it's not that they're equal, that will go through the whole array. And that kind of sucks. Because if the array is very long, and you want to check if like the first 10 are correct, then you'll end up with a big problem. But of course, in this case, it's the whole array. So yeah. Now from here, we just have to update some of our functions for these in order to be more in line with like how they look in code. I'm gonna swap their order around. This is just purely because I like doing it this way. I think that it just makes it easier to understand that I forgot about this operator existing. So from there, you can just double check that everything is in fact there. Okay. So then we have a couple more instances to deal with. So operator string, that'll just stringify. By default, it's 0, so we'll just pass in like that. Then we have our array operator. All this will do is, if it's an array, return the array. Otherwise, just return an empty one because you don't want to do anything. And then from here, you'll more or less see that it's the same kind of deal. Rather than casting numbers between, say casting down for array ref, we are instead just gonna call float. We are just gonna make it so that if they're the same type, or if the type isn't in int64 array, it does return. Otherwise, it just gives you an empty array. And that way, it saves a whole bunch of time and a whole bunch of data choke points. So below here, we do have a couple more things to add. So if you'll be aware, we also added new constructors. So like follows. Placement new just creates a string from B string. Same thing here. Array doesn't really... Hold on. No, array does need to be changed. Hold on. New. We're going to do placement new instead of data mem of array from type P array. I think I ended up doing that because it was non-const for this constructor, but it should always be const, so whatever. And the type is then array. And that should fix some problems we might have had. Then it's the byte array stuff like follows. We just create a data type of that and then register it, and then we're all good there. All right, so that is our variants fixed, basically. They should function a lot better, and they actually support arrays properly rather than pretending to support array and then anything breaking will try to do anything else. However, there is one more thing we're going to do. We're going to go into array, and of course, there is things we need to fix in array as well. All right, nothing on that level, and we're going to check inside array, and oh boy, would you look at that. There's a couple of things we need to fix. So within here, we are going to... We've already included atomic counter in the header, which I think is a bit... Oh, no, should be okay. I can get rid of that and then just include that here because it's in... Yeah, okay, all good. Based on this comment, you know what's going to happen. We're going to replace this with a ref count. And we're going to have to change a bunch of the code. So for instance, in unref, if instead of if data is freed, if data .ref count unref is 0, then we delete the data, which we're going to do like so. Oh, other thing here that I've noticed. When we are appending, I'm gonna make sure, wait, hold on. For append, yeah. So these need to be const variants so that we make sure that we're not actually modifying the variant itself, and so that the variant itself isn't being copied, which is a problem that you can have sometimes if you do it the other way. And same kind of thing with push random pushback. You want to make sure that everything doesn't break on you like so. And then fill as well. And then you just go here and update the list the same way. And from there, our array class is also fixed. So now everything should hopefully work a lot better. In order to test this, we can go to our setup function. To make sure this works, we can include from core variant.h. And in here, we can now do some fun. So let's make an int x, and then an array z, say, and z.append x, z.append, let's say, hello world, like so, z.append 3.141. Then let's create a byte array. So byte array BA. And then we're going to append 0xf because I'm feeling fun. BA.append 12.append 255. And then z.append BA. Like so. Build. We should see that everything compiles, no errors, all good. Hit F5 and it should run. Never mind. Ooh. Oh, okay, I see what's going on here. Right, that was a very silly error. If you want to know what happened, effectively, when we call to reint to a case, once you're done in that case, you need to break so it doesn't try to do the next thing. What it did is, even though the type isn't an array, it then went and tried to free it as it were an array, which it's not for reference. So that's what was happening there. Another thing I also forgot to do is we don't actually get to see our results. So I'm just going to call to print z dot let's call variant z dot stringify, and really we should have a stringify for array itself, but we'll do it this way. Okay, so build again. There's horrible amounts of constructors here, but hopefully it runs. Okay, cool, it does. And you'll see here that it's not really working. Of course, there are elements there, like x isn't null. But in our case, because we don't have number printing, it is going to show up like that. But aside from that, that's pretty good, because it means that numbers will print should they add, and everything we've written is all good. And in addition, these byte arrays do actually do stuff. And the best part for me personally is the fact that now we can see the output in the console. So we can close the window. You can get rid of this code. I'll leave it in just so that you guys can see. And that's us pretty much done here. So I would like to thank you for watching. I know this has kind of been all over the place, fixing stuff up, but hopefully you'll see the rewards of that later down the line. Episode after this should be episode 16. I can't remember if I've put anything between. But that episode, we're going to be working on the files system. And from the files system, we're going to start being able to move some of this code, or specifically this, out of main and into a separate shader file that we can load. And once we've done that, we can start moving things like this code into a rendering server and then start developing our rendering server from there. There'll also be, just for additional reference, there will be a kind of commit overhaul. Effectively, what I'm going to be doing is I'm going to be going through all of the code that we've written so far and documenting absolutely everything we've written, so that when we go back to look at it later in the series, try to figure out what we need and what we don't, it will all be documented for us to know. Aside from that, do hope you enjoyed this video, and I'll see you in the next one. A bye.